Okay, so today's video is going to be really short. It's going to be on transformation of random variables. And in this section, we're going to do a couple of things. We're going to talk about linear transformations of random variables. The trickier part is going to be combining, but that's tomorrow's video. And calculating and interpreting what happens after we combine. But that's tomorrow. Today, we're just going to be doing this. Describe the effect of performing a linear transformation on a random variable. This is really just review of stuff we've already done and putting it together in a slightly different way. So in section 1, 6.1, we learned that mean and standard deviation give us important information about a random variable, where we can actually find the mean and the standard deviation of events that are going to happen if they're following a probability model. And so in this section we'll learn how mean and standard deviations are affected by transformations. And we've done this before. We did this in chapter 2 where we talked about if we do something to all the data points, what does it do to the mean, to the center, and to the spread, and the shape of the distribution. And so this is the same thing. It's just that instead of doing it to each data point, we're doing it to the outcome of some random event, but in the long run, we'll get the same effect as we had before. And that effect is if you add a constant to each observation, it adds a to the measures of center and location. So if we had a distribution of a random variable, right, if we added something to it, it would just move it. The shape would stay the same, right? And the center would be the same as if we added A, because we added the same thing to every single one of them. It does not change the shape of the distribution, and it does not change the spread. Multiplying, though, will change the measures of center and spread. So let's talk about what happens when we multiply. So we have that same distribution. But now we're going to multiply everything. Okay. So that is going to change the center. That is going to change the spread. And it changes how spread out the distribution is, but it doesn't change what we refer to as the shape of the distribution. The first distribution was right unimodal and ever so slightly right skewed, and the resultant distribution is still unimodal and still slightly right skewed. So how we would describe it is the same, but it does change the set and the spread, the center and the spread. The big one is this one, is that when we add something to the random variable, it does not change the standard deviation or the IQR or anything else like that. And this is just that same information written mathematically. And the only tricky part is that when we do the standard deviation, we multiply by the absolute value of B, because standard deviation is always a positive number. And since B could be negative, the mean we don't do the absolute value to, but only the standard deviation. Because remember, part of the formula standard deviation was squaring, so all the numbers came out positive, and therefore we would wind up with a positive number for standard deviation. So that's it. That's all we had to do. Is it's the same rules apply to transformations of data sets apply to random variables. And we'll play with this a little bit in class. But otherwise, short video today. I'll see everybody next time.